Hello again, it's Ingmar. Welcome to our next session where we are working on our little, vertically scrolling shooter game, our little Starship game over here. And I prepared a little sketch using p5.js. As you remember, we already introduced the background and the scrolling star fields, and now there's a little white square in the middle of this sketch, and this is just a placeholder for our Starship, which we will introduce during this session. We can move this little dummy right now with the arrow keys, and later on in a session following this one there will be a 3D model or something like that, maybe some renderings. We'll see what will fit our needs with a real Starship. But for the time being able to navigate this little Starship with the arrow keys will be, our first goal for this session. Okay, now let's see where we left off. The last time our little sketch looked like this, just the background, and in the front then the stars are kind of raining down or coming down from the top. So we can get the illusion that the camera is moving in the other direction. And of course that's the idea, because we want the Starship to move in this direction, or to look like it would move in this direction, and our enemies or asteroids will be coming from the top. Okay, but first our Starship, we would like to have a little container and move that upwards. Okay, now we already have a bunch of JavaScript files, for example starfield, which manages the star fields and the background image, and I would like to add another one. I just hit the stop button right now, and yeah, you guessed it, of course it's the Starship Js. So a single file, a single JavaScript file, which will help us managing our Starship class, which will reside in that file. Right now the file isn't existing. This can be helped. I'll create the file and say, okay, let's get the Starship JS right there, add file. Okay, so there the file is, and what we will do is we will introduce another class, and of course the class will have the name Starship. So there we go, another JavaScript class. So now let's think about this. What do we need? Of course we will need a draw method, so that we can already implement, which we will call every time a new frame gets drawn. So this is necessary, we can't get around this. Then we'll also very likely or highly probably need a constructor where we pass some parameters to this class. For example, the dimensions of the Starship, or the size with which it will be displayed upon the drawing area. So we will have some fields, for example width, and this will take the amount given with a parameter also called width, and of course I need the parameter. I do not have this already. I could initialize this with a parameter given in the constructor, and height also. So this height will be the amount given via the parameter. So all right, now we have height and width. That's almost all we need to draw a square, and now let's do just that. Implement the part where we would draw the square, and you already have seen the square. It's white, so just take 255 as value for the fill method or fill function. And then we say, hey, give us a rectangle, which will be placed at, well, yeah, that's something we forgot. We need the position as well. The dimensions of the rectangle aren't enough. We need an X and a Y position. So this we will also need to add in the constructor. And then we can say, okay, draw this rectangle with the height and width given to this instance of the class. So, all right, now we just say this X will be, well, where do we place it? We've got a drawing area and of course the global width variable, which we can read from, and then we'll see the size of it. Problem is now, since we already defined a parameter called width, this won't work. So maybe it's a bit better to rename our parameter and say, okay, this is just width param and height param. Oh, it's still a bit ugly, but well, just let's keep it like that, and we'll fix the wording later on. So, okay, now you see the color of the word has changed. It's now some kind of, well, magenta, pink, whatever. And we can work with the global variable named width, and we will take half of it. Because if you think, if you remember, we've got a square right here, which is, I think we initialized the sketch with 400 pixels width, and we want to place it in the middle, right on the bottom and in the middle of the sketch. Then we, I think we are well advised to take the width of the canvas and split it in half. And then we would start to draw the rectangle right from the middle and then to the right. Okay, that is close, but it's not exactly what we want. We actually want it right in the middle, to be displayed in the middle of the canvas. So we need to subtract the half of the own width of the Starship. So we have the width of the canvas, and we take half of it, and then we subtract the half of the width of our little Starship. Okay, let's see where this will go. With our second parameter, we need, of course, our Y parameter for our position. And there we've got, of course, the global variable height. And height is, well, as you maybe know, p5.js and processing starts to count from the top, and then the Y value increases with distance from the top. So the arrow is actually down. And well, yeah, okay, height would be the end right there. And if we start drawing right there on this right on the lower edge of this area, then we wouldn't see our rectangle. Now we can do this. I will include an instance of the Starship in our little sketch.js. Let's do this. So let Starship. So we've got our Starship in the setup. We will fill or set our Starship as a new instance of Starship, and well, what do we need? Oh, let's say 40 pixels in width and height for the time being. Now there's a Starship, UBA. And now let's see what we do down here in the draw method of our little processing, or rather p5.js sketch. There we can add our Starship instance and just say draw. Basically, that's the idea. And it has to be placed at the bottom or in the last line because we want the starship to hover above the background. Otherwise, it would be overlaid by some of these stars. Well, that could be an interesting effect, maybe for some special level or something like that, but for the beginning, I guess it's nice to see what we're actually doing. And so I'll draw it on top of the rest. So, okay, now let's return to our Starship class. This should already draw a rectangle. Let's stop the sketch and restart it. And, well, nothing happens. Well, as I said, the height is the complete height of the sketch. And since p5.js starts to count at the upper border, at the upper edge, actually starting to draw with a height as a y parameter will draw some kind of rectangle down here. So we can't see it because it's outside of the visible area. So this is not what we want. Just test this and we'll just reduce the amount by, let's say, I've written too much CSS lately. Now retry this. This should make it visible. There it is. See? So now it's sitting right here. It's a bit, maybe we could put it a bit lower on the screen so we won't reduce the height that much. Let's say 70, for example. Okay, let's try this. Yeah, I think that's nice. This is okay. Well, now we've got a starship. The trouble is, it's pretty much, well, as much as I push these buttons, nothing happens. So would be nice if we could actually move the starship around. So let's see what we can do. Well, we've got a class called Starship and we've got a method draw. Would be nice to have a method move, wouldn't it? So we could change the positions of our starship. Now let's think about it and let's try this out. Let's make a move. So there it is. The name move for another method of our little class. And well, we want to change the position, so I guess two parameters x and y might be useful when doing this. So when we are calling the function move or the method move, we can say in which direction the starship should move. Okay, now let's have this super easy. Let's say we just take the current x value, add the x from the parameter. So this bluish one, this one, is the parameter. We'll add this to our current position, which is stored in this dot x, and our new position becomes this dot x, just like this. We could write it a bit shorter in JavaScript. There is an operator looking like this, a plus sign and an equal sign, and that just adds to the field standing on the left side the amount you put on the right. And we'll do the same thing for the y field, for the y property of this class. And well, then with whatever we put there, for whatever we choose to set our x and y parameters to, this will change the current position of our starship. Okay, now let's see what we can do with this. Return to our sketch, and then, well, let's just call starship move right here. Okay, this of course will still be a bit off of our goal. It's just a little test. So let's keep the x position where it is. So we'll just pass a 0 value here, and we'll pass a -1 value for the y parameter. So my plan would be that this one, this little dummy or little placeholder for our starship, will start to move upwards. We still can't steer the ship around, but at least it will move. So we can test this. If it doesn't, then maybe I made a mistake. Let's see how this works out. And yeah, it moves upwards. Fantastic. Okay, so our move function seems to work. At least basically we might need to readjust it a bit. For example, what we do not want, right there, if we wait a bit, we do not want our starship to leave the screen. Right there. Now the craft is gone, and well, the player is on blind. He doesn't see his starship anymore. So that's something we might want to prevent from happening. But this we will face this later. The first thing I really want to implement is the moving around, controlled by our arrow keys. And that is one thing we can do with some, oh, where I prepared something, but where is it? Where is it? Where is it? 1 second, I've got it. Yeah, right. So what we can do is, and then I guess we should move to the Starship class, right there. We could include into the draw method our manipulation of the position. There is a method in p5.js called keyIsDown that checks if a key on the keyboard is just right now when this method is called, if a certain key is pressed. And for example, you can ask, hey, is the left arrow currently pressed? And only if the left arrow is currently pressed, this method returns true, else it will return false. So every time draw is called right now, we could ask if the key left arrow is being held down by the user. And in this case, we very much would like to move our arrow to the left, our little ship to the left. So this, and now this would be of course the X parameter. This should change. We could implement it right here, but we already implemented our move method. So I'll just say, okay, let's reduce the X value and leave the Y value. So just move 1 pixel to the left. Now, it could also be that another key, the opposing key, the right arrow, is pressed. So I'll just ask, alternatively, maybe the right arrow is pressed. And if both are pressed, then, well, the left arrow will be evaluated, or the part of this, of our little condition right here. So right arrow. Now open up, and this, and we call move again. And now you guessed it, it's of course 1 and 0. So we've got the right and the left arrow, which when pressed, or when being pressed over some kind of time, some amount of time, then these arrows should have the effect that our little starship is moving to the left and to the right. Let's see if that already works. So, oh, I made a mistake. Yeah, of course, there's an if missing. Oh, let's go, there we are. And I've got to activate the area, and then right now I'm moving to the left, and we can move to the right. So this seems to work, actually. Now, that's all very nice and proper, but I would like to also be able to move the ship to the front and to the back, or, well, increase the speed and slow it down, accelerate, and, well, yeah, just decelerate the starship. So we need something like that for the up arrow and the down arrow as well, and this will be the next part. We'll check if the up arrow is pressed, just the same way we just did with the other arrows. And there's also a constant right there, which I can use right here for the up arrow. And then we will once again call this move. And now, of course, it's not the X value, it's not the horizontal axis we want to change, but the vertical axis. We want the Starship to move up and down. And for the first part, this will be up. So I now need a negative value, because we're starting, remember, we're starting to count at the upper border, at the upper threshold, and then the values of y increase when all this goes down. The reason for this is in computer science that we are working with rows, with lines of pixels, and he starts to create the first line of the first image in, yeah, well, whatever milliseconds or nanoseconds they are needed for, and then the second line, the third line, and so on. And so this, well, this line counting translates into our y values for this little sketch right here, and for a little Starship. So, and then of course the counterpart key is down, and now for the down arrow, there it is. And well, we'll just invert the value we passed in line 22, and now we should be able to move our Starship around like it's 1999. Well, yeah, whatever. So let's test this. Yeah, I've got to activate the area, one click. So now the browser knows that I actually want the p5.js sketch to receive my my orders, my commands via the button press, and horizontal movement is still working. And now we also have vertical movement, and if I press two buttons, then I can also move in these 45-degree directions. So it's still a bit, yeah, well, I think we could improve upon the acceleration behavior, maybe some boosting later on with some rockets or something like that, so it accelerates much stronger for the forced part, and then when the rocket is burnt out, it becomes a bit slower or something like that. We can all play with these parameters, but the first step is successfully taken. What still remains as a problem is that, well, I can just bring our little Starship out of sight. That's a flaw. I don't want this. I would like to keep our Starship on the area every time, in all time. So, okay, now let's do this. Okay, so we want our move method. This is where the magic happens, remember? We want our move method to control this. Yeah? Whatever comes as a parameter to the move method, this should be checked. So, and now, well, how should this work? I mean, the method gets a new parameter and then it moves it around, and well, how should the move method know where the Starship will be? Well, of course, there's something like mathematics and arithmetic, so we can actually calculate the point where the Starship will be if everything was calculated just the way it is right now, where I can move the Starship outside of the boundaries of this area. And we will do this up front. So we'll first calculate where the Starship will be, then we will check the value where it would be if the method would run regularly, and if this new value would be outside of our borders. For example, I would like to stop it right there. I don't want the Starship to hit the threshold or the the edge right there, then we can say, okay, if your new x value in this case is greater than a certain threshold, then this will not be assigned. So the user will keep on pushing the right arrow button, but nothing happens if the Starship is already at the rightmost position it can achieve or it can reside in. So let's see, how can we do this? Now, of course, we need to calculate the future or something like that. And we will introduce a new variable, and that would be next x. So that would be the next x value if everything works out fine and no thresholds are touched, at least the horizontal ones. So, okay, how do we do this? Well, of course, we take the x value of the current position, which is this x. We just read the field from the current class. And then we add the parameter given to the method. This is pretty much what we do right here, but now we don't assign it to this x. We just store it in our little local variable called nextx, and we will check if nextx is too far on the right or too far on the left. So, okay, how do we do this? If, and then we need to check our value. Nextx is bigger than width. This would be the right border minus, and then we need some kind of threshold distance definition right there. Just put 20 right there, so we've got 20 pixels to the right from the right border. And if the next x value will be bigger than this, then, well, we can tell the method that it should just return and do nothing. Okay? So, on the other hand, if the threshold holds, if the threshold is holds and isn't even touched right now, we can just put the next value, the next x, into this field. So there it is. In the background you might hear my girlfriend coming home and greeting our cat. So this is totally normal and expected. Good. Now let's test this. Stop this and let's start again. And now I will, after activating the sketch, I will move the Starship to the right and, well, okay, that's, well, maybe we need a threshold much more to the left, but it holds, It's too far on the right, but it holds. And maybe we need something like 50 pixels. Not 20, but 50 pixels. So let's do it again. Is this more accurate? Is this better? Let's see what happens, and there we are. So I can't move any further to the right. Actually, I can't even move to the, yeah, okay. The vertical movement is deactivated right now, but the right threshold, the right border holds. So this works fine. But if I move to the left, let's see, there I can still move our Starship completely out of sight. That is not what I want. So I will add another condition and say, hey, okay, if the next x is, yeah, well, let's say smaller than 10 pixels, then you should also return and do nothing, because, well, then we would move out of the area right here. So restart our sketch and test this, reactivate the area, and let's see, bam, no, it doesn't work. That is unfortunate. Why doesn't this work? Strange. Did I forget something? So width minus 50, that works for the right border, and if next x is smaller than 10, it should stop. Interesting. Okay, let's increase the value right there. Maybe this will make it visible. See what we can do. Shoop-de-doop-de-doo. And no, I can still move it out of sight. So, alright. And the right border, no, the right border also doesn't hold. What did I do wrong? Of course, you see, I said when both conditions are true. This is of course a grave blunder. It's enough when one of these conditions is true, then this method should exit without doing anything. And the sign for either or for a logical or is these two pipes. You can generate these signs with Option and 7 on a regular macOS keyboard or Mac keyboard. If you're using other hardware, then you will be, of course, able to find out how to get this while Googling about it. So now let's try this again. Reactivate our little sketch. And let's see if the threshold to the right holds. Yeah, it holds. And now let's go to the left, to the left, to the left, to the left, to the left. And okay, this is maybe a bit early, so I could decrease the value again, say it like that. Okay, redo it, restart. And yeah, okay, there we've got 10 pixels distance. Fine. So this works for the X value. Now let's re-implement our Y value. Let's have another variable which looks into the future. Our next Y value will calculate this up front and not assign it directly. We're reading our current position and we're adding whatever the move function gets as a Y parameter, and then we'll have another condition, and that will be just as the same logic we apply to our X value, our next X value, but of course here we need to have a look at our height, and we will take just the right or just the same values right there. So the next X will be the next Y will have these values. So we'll get approximately, I think this will be a 10 pixel border or distance, and then our ship won't be able to move. So, and then I'll write return, which tells our little method that it shouldn't continue with execution. So, okay, let's test this. We can optimize the code later on. So stop this, reactivate the play field, and okay, this works. And what I did, of course, I forgot to assign the value to the Y variable. There we go. So restart, and now I can move in all directions. That's nice. To the left, there we are, and to the bottom, and stop. I can't move beyond this area here. This is exactly what I wanted, and when I go to the top, then I will hopefully, yeah, I can't move further to the top than this. So now we've got a little Starship dummy right here. Well, we could increase the speed maybe a bit. We could think about that, well, let's say, well, pump up the volume, and we'll improve our engine here and say, okay, let's move 3 pixels each time in any direction. Might look a bit strange, but well, we'll see. Okay, but we'll have another problem after that, because bam, up right there. Okay, it still works. That's fine. what could have happened is that, oh no, it's all right. It's all fine. Well, of course, you're going to have, you have no blur, no motion blur right there. We could implement that as well. But I would say, okay, that would be a feature for some of the future sessions. For the first part, this is all fine. What I would like to do is to reduce this chaos right there. Well, for once, I would like to have a variable defining the distance to the edges of the drawing area. And I would like to call this distance to drawing area. So this is 10 pixels. That would be nice. So now I've got the problem that when I am drawing a rectangle, this will be done from the uppermost left corner, and then width and height is applied to that. So that's why we have these different values over here. I can already take distance to drawing area and put it right here. But I also have to calculate this one. So where does these other 40 pixels, where do they come from? Well, of course, this is the width of our Starship. So if we go here and say this width and distance to drawing area, which is a bit long, maybe we should shorten the name, then we should have the same effect just as we see it right here. And same for the height. I just put it right there. Now this should actually do the same thing we are already seeing here. Okay, let's try this once again. Activate this. So we're here. Yeah, thresholds are holding. That's nice. Okay. Now there's another problem. Let's first make the name shorter. It's hard to read. This is ugly. So let's say this is just our distance to the border, and then let's have it like that, which is much shorter and much clearer. So as you see, we are actually repeating ourselves here, and we could have one return instead of two. So if we just use the logical OR, the logical gate again up there, and we are moving our conditions from the second if to the first if, then I am pretty optimistic that this will still work. So now maybe we should adjust our typography, our coding style a bit. It looks like that, so it's a bit easier to read. White space is not the problem in this case. We could get this to, yeah, okay, so this looks a bit more acceptable. Yeah, okay, so now let's try it again. Stop and go. And now lower border, lower threshold is holding, right threshold is holding, left one also, so vice versa, I mean, and the topmost threshold is also holding, and we are moving around quite fast. This is quite nice. Okay, so that's it for today. I hope you enjoyed our little session. Of course, the code will be available for you as soon as this video is uploaded. I will add the link to this sketch, to the code, in the description. And well, that's it for now. So far, have fun. Bye. See you next time.